Hello again. My name is Christopher Gonzalez. I hope everyone is doing great today. Today's topic that I will be discussing is large language models. These are the brains behind a lot of the AI technologies you interact with every day. Ever wondered how devices like Siri or Alexa come up with their responses? Well, that's the work of LLM. Today, we're going to explore how these smart systems learn. On this slide, the topic is pre training to post training and post training data conversations. I'm going to go over some key points here. One of them is pre training. This is models learn from a broad data set to grasp language fundamentals. Second key point is how it transitions to post training. Models are fine tuned with conversational examples to adapt to specific tasks. And last key point of this slide is post training data. Focuses on conversation, quality, and appropriateness. So let's start by talking about how these smart models learn to chat like us. Initially, they go through what's called pre training. Just like a little child, they need pre-training, how to walk, how to use the bike. Well, not babies, but kids. We all need some sort of pre-training before we do anything. So, where they soak up a ton of information from across the web to get a grip on our language, right? This is for AIs and um, large language models. Think of it as their schooling phase. Next up, they move into what we call post training. This is like their on the job training where they practice on actual conversations to get real good at understanding and responding in ways that make us, well, that will make sense to us. It's pretty cool how they evolve, right? So on this slide, uh, the topic is hallucinations, tool use, knowledge, and working with memory. So one of the key points is hallucinations. This is challenges in ensuring factual accuracy. Um, the second key point here is tool use. Models use external tools to fetch real-time data and improve responses. And also the last, uh, knowledge versus working memory. Compare stored knowledge with temporary task specific. Okay. So sometimes these AI models get a bit creative, not always in a good way. They can come up with what we call hallucinations, which are basically facts they make up. To help keep them honest, we can now use tools like Google to look up real time accurate info. And about their memory, it's a bit like ours, but split into two parts. They have a long term memory, sorry about that, where they store all they've learned, and a working memory they use to handle whatever we've asked them about at that moment. So they gather information, and um, now that we have Google, the LLM actually gets information by Google and actually gives you accurate information. So let's move on to the next slide. So on this slide is knowledge of self and models need tokens to think. So we all know what tokens are. Um, it's pieces of text that you input into the prompt, and it gets those tokens, splits that sentence into tokens, bits of information, and it puts it through the LLM. So Here's another key point: knowledge of self, how models perceive their own identity, and dependency. Sorry, the necessity for models to process information in manageable pieces. We all know what tokens are. Ever wondered if these AI models know who they are? Well, they don't really have a self-awareness like we do, but we can teach them to understand what they are and what they can do, which is pretty handy, because then they'll be all over the place. They're not going to know what they are or what they do. And here's a fun fact: they think in tokens, small chunks of info, one piece at a time. It's like how we break down a big problem into smaller bits to make it easier to handle, which are tokens, like I discussed earlier, that a sentence could be break down into words, and those words will know what's in front of them or behind of that specific word that we're trying to figure out, or that sentence. So off to the next slide. So jagged intelligence. So here's an uneven capabilities. Models excel in some areas but falter in others. Uh, it how it impacts on of training, how training, breadth and depth affect performance. Here on the right hand side, we have a chart. It's an estimated chart how it shows the performance score and how it goes up and down. If there's how it fluctuates sometimes, the performance of the AI model, and also it has the task at the bottom of the graph. So yeah, so you might notice that sometimes AI seems super smart and other times not as much. That's what we call jagged intelligence. In some tasks, like playing chess, they're geniuses, but in others, especially those needed a human touch, they can be a bit clumsy. But all about how they were trained, which really shapes what we're good at and what they struggle with. Supervised fine tuning to reinforcement learning, RLHF. Supervised fine tuning, refining responses based on specific training sets. Okay, the last key point of the slide: reinforcement learning from human feedback, which is RLHF. It adapts model behavior based on user interactions and feedback to promote desirable outputs. As we wrap up, let's talk about how we fine tune these AIs. It starts with something called supervised learning, where they learn from examples we carefully select for them. Then we graduate to learning from their own experiences through what's known as reinforcement learning from human feedback, which is RLHF. This means they get better and smarter based on the feedback we give them. Learning what works and what doesn't in real conversation, it's like they're constantly updating their skills based on little help from their human friends. So we reached the end of our journey today, and I just want to take a moment to thank you for all sticking around. I hope you find the insights shared as intriguing as I do. It's been great having the chance to dive into these topics with you. If something sparked your interest or if you have any questions, I'd love to hear from you. Let's keep the conversation going. Take care, stay curious, and I can't wait to catch up with you in our next session. Thank you.